Welcome to Honors Physics Podcast. This is question number 59. We have a helicopter lifting a 2,100 kilogram Jeep. The steel suspension cable is 48 meters long at equilibrium. That's an important thing, and it can be modeled as a spring with a spring constant of 25,000 newtons per meter. So if the helicopter is suspending the Jeep motionless in the air, how long is the cable? Well, in that case, we have a downward force of mg, and we have an upward force of our kx. Because we're suspended motionless, that means that our kx is equal to mg. Remember, x, that's our compression or stretch distance. So compression slash stretch distance. So this is not going to be our actual length. This is going to be how much it has increased by. So we plug in 25,000 times our x, and that's going to equal 2,100 times 9.8. And so if we just do a quick calculation with that, that gives us a stretch distance, and it's going to stretch because we're pulling down on it, of 0.823 meters, which means our total length is going to be equal to 48.823 meters. Okay, now as we accelerate upward, we don't have kx equal to mg because, in fact, we still have our kx coming up. We still have our mg going down. But in this case, we have a net force going up. So our F net will be going up toward the sky. And in this case, our F net is going to be equal to our upward forces, which is kx, minus our downward force, which is mg. So kx will equal F net, which is ma, plus mg, which makes sense because our spring force must be larger in order to accelerate upwards. So it's going to be 4,100 times 1.5 plus 9.8, and that's going to equal 25,000 times x. So as we do that, we end up getting that our stretch distance here is 1.853 meters. And so what that means again is that our length is our 48 plus 1.853, or 49.853 meters. And this is question number, let's see, this is 59. Question number 59, chapter 10 homework.